Hi everyone, let's go ahead and look at 9.1, adding and subtracting polynomial expressions. So whenever we add or subtract these polynomial expressions, we need to make sure that each term first is a polynomial. So to make something, or to determine if something is a polynomial, we're going to be looking at the exponent of each one. The exponent needs to be a positive whole number. All right, so let's go ahead and look at the ones that I've got listed here. And I'm going to look at the exponent of each one. So for example, this one has an exponent of 2. 4x is to the power of negative 2. This one here has x. It doesn't have an exponent that we see, but that exponent is an understood 1. Then this one here has an exponent. It is x to the 1/2 using the power over the root to rewrite that. So that power is x to the 1/2. This one here has x to the 1/4. This one has x in the denominator and it has the positive 2. This one has an exponent of 2 and an exponent of 3. This one has x, which is the exponent. Down here we've got x in the denominator. This one does have an exponent of 1. Okay. Down in the denominator. And then we have an exponent of positive 3. So looking at just the exponents, if the exponent is a positive whole number, then it is a polynomial. So let's see, this first one, 2 is a positive whole number on top of the variable x, so that one's a polynomial. Negative 2 is not a positive number, even though it's a whole number, so that is not a good term for a polynomial. This one, x is in the numerator. As long as x is in the numerator, we can have a polynomial. If x is in the denominator, it's not going to work for us, and I'll show you why in just a few minutes. But x is in the numerator, it has a degree of 1. This is a good polynomial. Next one, x to the 1/2, not a good polynomial. X to the 1/4 is not a good polynomial term. And then let's go backwards here. Negative 2x to the 3rd. 3 is a positive whole number, so this is a good polynomial term. Next one, 5x to the 1st. So the reason that this one doesn't work is because I rewrote this. It would be 5 times x to the negative 1 when I move it to the numerator. So x, the exponent, cannot be a negative number. So whenever you see that x in the denominator, this will not be a good polynomial term. 7 to the x, this x right here needs to be a positive whole number. We don't know what x is, so we're going to say, nope, that's not a good polynomial term. X squared, y to the 3rd, those are both good. And then the last one, x squared minus 4. Now keep in mind that when we see that x in the denominator, we're going to go ahead and say not one that we're going to look at. Okay. All right, so then we have, what are like terms? Like terms is an algebraic expression that has the same variable raised to the same power. So we're looking for things that they have in common. I have 1/3 x to the 4th and negative 6.5 x to the 4th. So the part that makes them alike is x to the 4th. So when they have the same variable with an exponent, we can add or subtract the coefficients that are in front of x to the 4th. We can combine those two. All right, next one, what do they have in common? They have x squared, z. So that means that since they both have that, we could add or subtract whatever they ask us, 4 and 5/2. All right, this last one here is a squared times b times c to the 5th is what they both have in common. Now, whether they were asking us to add or add or subtract, we would add or subtract the coefficients. Okay? So again, that coefficient is that number in front of the variables. It tells me how many copies of that group that I have. Okay, let's go down here and look at the sum or difference of these given expressions. All right, I'm going to notice first that I have my first polynomial and I have my second polynomial, and they are subtracting these polynomials. So whenever they have subtraction, we're going to go ahead and convert this into addition. So to do that, I'm going to multiply this negative times another negative. But if I do that, I also have to do that to everything in this equation. Okay? So negative times a negative would make this a positive. A negative times that first term is going to make it negative. A negative times the second term is going to make this a positive. And that negative in the middle times this last term would make this a negative 5. So we have 6x minus 1 as our first polynomial, plus negative 3x plus 2x squared minus 5. Right? So when we write this in standard form, we're going to look for the one with the highest degree or the highest exponent, and that would be positive 2x squared. And no other terms have 2x squared, so that's the first term. Now we look for any of them that have just an x. So I have 6x minus 3x. 6 minus 3 is positive 3x. Then the last piece I need is the constant terms. So I have negative 1 minus 5 is negative 6. Okay. A really huge piece that I want to emphasize. If it has this negative here in the middle, change this negative so that it is a positive. It'll leave less room for mistakes, and it seems to work out better when we're combining like terms, so we don't have to distribute a double negative or even think about distributing that double negative every time. All right, so what's my leading term? My leading term is the first term in the polynomial. So the leading term is 2x squared. What's the leading coefficient? Well, the coefficient of the leading term is 2. What's the degree? The degree is the exponent, the highest one. So in this case, that would be 2. And then what is the constant term? The constant term is the one without the variable. So that's negative 6. Okay, let's go on to example B. On example B, you'll notice that they are already adding. So we don't need to change the sign of everything. So let's go ahead and just combine like terms. So I have 4x squared plus 2x squared. That gives me 6x squared. Then I have negative 3xy plus 1xy. So that gives me negative 2xy. And then my constant term, we don't have one, but I do have a variable term with just y. So 2 minus 3 gives me negative 1y. So my leading term is the one that's in standard form, is leading the whole polynomial. So that's 6x squared. The leading coefficient is the number in front of that polynomial. So that is 6. The degree is the largest exponent of the polynomial, so that's 2. And the constant term, there isn't one. Now, when there isn't one, that's because they're still adding 0, but we don't write adding 0 to see it. So the constant term is 0. All right, I've got some problems here for you to try if you'd like to, but you have the assignment online. If you look on Canvas, it'll tell you where the assignment is, and it is on adding and subtracting polynomials.